I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we are going to see the next topic as Waveguide Tee under the unit Microwave Passive Devices. So, microwave passive components and the importance of microwave passive components are used inside the microwave measuring instruments, and they are also used to combine the instruments to create more complex measurement systems. In all cases, these microwave passive devices will split, combine, filter, attenuate, and or shift the phase of the microwave signal as it propagates through a particular transmission system. So some of the examples of microwave passive components are power dividers, are also called as T junctions, and in T junctions we are going to see in this video as two type of T. One is called E plane T and another one is H plane T. And other type of microwave passive components we know it is directional coupler, magic T, attenuator and resonators. So now in this video we are going to see the particular component, microwave passive component, the T junctions. So the microwave T junction is an intersection of three waveguides in the form of English letter T. So they are called as T junctions. There are several type of T junctions. In microwave circuits, a waveguide or coaxial lines with three independent ports is commonly referred as T junction, which is shown in the diagram. So they are used to connect branch or section of the waveguides in series or parallel with the main waveguide transmission line, and they provide the means of either splitting the power or combining the power in a waveguide system. So the two basic types of T are, one is called E plane T and the other name of E plane T is series T, and the second type of T junction is called H plane T and its other name is shunt T. So we'll see the T junction one by one. The first type we'll see the series T or E plane T. So this E plane T is a waveguide T junction in which the axis of its side arm is parallel to the electric field of the main guide. Because of this reason it is called as E plane T. So here ports 1 and 2 are called as collinear arms and port 3 is called E arm or side arm. And a rectangular slot is cut along the broader dimension of a long waveguide. In this way, a side arm is attached. And E plane T, when the waves are fed into the side arm, that is port 3, the waves appearing at port 1 and port 2 of the collinear arm will be in opposite phase, but the magnitudes are same. So we can write S13 is equal to S23. That is the power in port between 1 to 3 is equal to power between 2 to 3, but same magnitude but in opposite side. So the minus sign is represented. But in general, the power out of port 3 is proportional to the difference between the instantaneous powers entering from port 1 to 2. And because of this reason, this is called as difference arm. So if two input waves are fed into port 1 and 2 of the collinear arm, the output wave to port 3 will be opposite in phase and subtractive. Sometimes the third port is called as difference arm. So E plane T is a 3-port network. So its S matrix is 3 cross 3. So S matrix is S11, 12, 13, 21, 22, 23, 31, 32 and 33. So but the scattering coefficients due to difference in arms, we can write S21 is equal, 23 is equal to minus S13. So the equation represents that The output sets port 1 and 2 are out of phase by 180 degree with an input port at port 3. So if port 3 is perfectly attached to the junction, we can write S33 is equal to 0. And now we are going to apply the symmetric property. We know that Sij is equal to Sji. So S12 we can write it as S21, and for S13 we can write S31, S23 we can write S23. So the modified S matrix of E-plane T is S11, S12, S13, S12, S22 minus S13, S13 minus S13 and 0. So now according to unity property, S multiplied by its complex conjugate of S is equal to unity matrix. So in this way, if we multiply R1 C1, R2 C2 and R3 C3, we get three equations. One is S11 squared plus S12 squared plus 13 squared is equal to 1, and S13 squared, S22 squared, S13 squared is equal to 1. S13 squared plus S13 squared is also equal to 1. So by simplifying everything, we get S12 is 1 by root 2 and also S11 is equal to S22. So by substituting all the parameters, we get the S matrix of E-plane T is 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2 minus 1 by root 2, 1 by root 2 minus 1 by root 2, 0. So this is about the scattering matrix of E-plane T. And next is the second type of T, waveguide T, is H-plane T, and it is also called as shunt T. So this H-plane T junction is formed by cutting a rectangular slot along the width of the main waveguide and attaching another waveguide. The side arm is called as H-arm. So here the H-arm or side arm axis is parallel to H-plane H field, that is the magnetic field. So because of this reason, this T junction is called H-plane T. And the port 1, 2 of the main waveguide are called collinear ports, and port 3 is the H-arm or side arm. And H-plane T is a waveguide T with axis of its side arm is shunting with electric field or parallel to H field of the main guide. And the other name of side arm is here called sum arm, where in E-plane T the side arm is called difference arm. So it is in H-plane T the side arm is called sum arm, because in H-plane T if two input waves are fed into port 1 and 2 of the collinear arm, and the output wave at port 3 will be in phase and they are additive. So hence the port is called the sum arm. And this is the diagram of H-plane T. There are two ports, and H-plane T is also a 3 cross 3 matrix, and you can see in the diagram the H-plane T side arm is perpendicular to the electric field but parallel to the magnetic field. And the S matrix 3 cross 3, and by applying the same like E-plane T, we get S23 is equal to 0, and by symmetric property we can modify the parameters, and also S13 is equal to S23, because when power is entering into port 3, it is equally split at port 1 and 2. Same magnitude, same phase. And finally, the S matrix of the H-plane T is given as 1 by 2 minus 1 by root 2 minus 1 by 2, 1 by 2, 1 by root 2, 1 by root 2, 1 by root 2, 0. So assessment questions. Why E-plane T junction is called as series T? And the diagonal elements of the S matrix of a resistive T junction. And the third port is of sum arm is called as H-plane T. The reason. Thank you.